Hello, in this video we are going to implement an AI system into our game. Because at the moment what we have is essentially like a two-player system game, and we implemented the win condition last time, but now we're going to create some AI which is going to be awesome. So first of all, you want to create some new files, so just create them in the normal way that you have been doing for your text editor or IDE. And you want a header and a C++ file. I'm going to simply call it AI, add it to my target, go to the AI.hpp, get rid of the contents, let's close all of this so we've got a bit more real estate to work with, hash pragma once, be hash include SFML /graphics.hpp, hash include vector, hash include array, hash include game.hpp, and this is going to be within, well, you know, the sonar namespace. Going to have a class of, you guessed, AI. Going to have a couple of public methods, the first being a constructor, so AI int player piece game data ref data. We'll be passing this in because we will need it. We're going to have a void place piece, so this is the only method that the game state will call. We'll have a bunch of private methods to handle all the different check-in, but this is the only method that the outside code needs to call. And this is going to have an int grid array 3x3, so we'll be able to modify the original value. SF sprite grid pieces, I'm going to call it pieces 3x3, and finally we want the game state as well because we'll be modifying that in here. Now we want some private methods, so for the private methods we want a void check section, and we're going to do int x1 int y1, and we're going to duplicate this, change this to y2, change this to y2. This isn't going to change to x3 and y3. This is going to change to y. So the check section, what this method is actually doing is, these are two pieces that are essentially already there, and we're checking if we were to place a piece here, could we win? So that's essentially what we're doing. And then we need to pass in the piece to check, so piece to check. We need to pass in the grid array, so int grid array, which we've actually got right here. So I'll save some time and copy and paste this like so. And now we need to pass in the SF sprite grid pieces array, and I'll misspelled pieces, comma, and I'll just need to spell pieces correctly here. Now we need to do check if piece is empty. Just gonna put some empty lines so it's easier to scroll up and down so you can see the code easier. Void check if piece is empty, int x int y, and now we need to have all of this. We're passing in this again, so copy this into here like so. Now that's it for all of the methods. We just need to create a int for AI piece, an int for the player piece, then we're going to have a std vector like so, and this is going to be an std array, and the actual data type is going to be int, and the size is going to be 6, and this is going to be the check match vector. So this will contain all of the various different checks that we can do to pass into here. There are a lot. I've already coded them up. Like I said, the first two sections are essentially places that pieces already exist, and the third one is where one could potentially go. Now we're going to do game data ref underscore data, like so. What you want to do now is open up your CPP file so we can actually implement the AI class that we just declared in our header. And you want to do hash include definitions.hpp hash include IO stream, like so, using namespace std namespace sonar AI : AI. So this is the constructor. Remember, it's int player piece game data ref data, like so. And in here we just need to do this underscore data equal the data object that we passed in, this player piece equal the player piece that's being passed in. And now I'm going to do a quick check on the player piece. If it equals the circle piece, then the AI piece is equal to x underscore piece, else let me just add some empty lines here so it's easier for you to see. Else AI piece equals circle piece, like so. Now we need to do all of that check match vector code. We can copy and paste it from here, like I said, to save time. Just go through these and have a look. They're very easy to understand. Now we need to implement the place piece. To save some time, I'm going to go to the header file and copy and paste. I'll actually copy and paste all of this into CPP file so we can just use them when we need to. Get rid of this line, get rid of that line. And now we just need to do AI : AI : AI : So in the place piece, we're going to do try. And for the statements, we'll implement that in a moment. Let's just sort out the formatting to the way I like them. We'll sort out the catch parameter very soon. So for try, we're going to check if the AI can win. So we're going to do if int I equals 0. If I is less than check match vector dot size, and we are just going to loop through the entire match vector. We're going to call it check section. So check section, and we need to pass in the check match vector I 0. And we just need to do this 6 times. Change this to a 1. Change this to a 2. Change this to a 3. Change this to a 4. Change this to a 5. And now for the int piece to check, and we are checking for the AI piece because that's who we want to check for. The grid array, we just pass in the grid array that's already passed into here. And for the grid pieces, we pass in the grid pieces like so. Put a semicolon there. So that's it for checking if the AI can win. That's the first priority. If the AI can win, then the AI is going to place a piece wherever they can win. The second priority for Tic-Tac-Toe AI is If they can't win, check if the player can win, and if the player can win, block that player. So we're gonna essentially copy and paste this like so, and we're gonna keep the check sections all the same. The only difference being here is going to be player underscore p, so that's what we're checking to block now. If that condition isn't true, so if we can't win, if the AI can't win, if you can't prevent the player from winning, then we need to check if the center is empty. These are the general rules for tic-tac-toe. You can easily change these. Recommend you do that. Implement your own AI system, advance on what you've implemented here. That's the best way of learning. So I'm going to check if the center is empty. So check if piece is empty. For this, it's going to be 1, 1, grid array, and grid pieces. Okay, so if the center is empty, if the center isn't empty and the other two conditions haven't been met, what we need to do now is check if a corner is empty. So for the corner, it's 0, 2, 0, 2, 2, 2, 2, 1, 2, 2, 0, 0, sorry. So 0, 2, 2, 2, 0, 0, 2, 0, like so. If none of these conditions are met, then we just need to check if any of the other spaces are empty. And for this, it's 1, 2, 0, 1, 2, 1, 1, 0. And now we're just going to do int error. For the statements, we're not actually going to implement anything, but it's there so you can handle it accordingly, and you'll understand why very soon when we actually start using this try and catch. So we're just going to do game state equals state plain. So essentially the AI's turn is now over, and now the player can continue playing. Now we actually need to implement the check section method, and for this we just need to check if two pieces match. So if asterisk grid array x, y, x1, sorry, y1 equals the piece to check, like so, and need to do the same for x2 and y2. So let's paste this here, go to x1, change that to x2 and y2. So if this condition is met, then the two pieces match. Now we need to check if the third piece is actually empty, because if it's not, we can't actually place one there. So if empty piece equals grid array x, y, grid PC, grid array x, y equals AI piece, semicolon, and I'll put the bracket in the wrong place. It should actually be here. So we set the grid array to the AI piece, because if it's empty we can actually place the piece here. Now we need to set the texture, so grid pieces x, y dot set texture, and for the texture this is going to be this underscore data assets dot get texture, and for the string name this is simply going to refer to the circle piece which we've already loaded before in our game state. Now we need to make it visible, so grid pieces x, y dot set color, and for this it's just sf color Remember, for the first three values, aka RGB, if we set it to 255, this will be essentially white, aka we won't actually modify the color, it will just be the original color. And we set the final alpha value to 255, this will be visible. We're going to throw -1. So this allows us to essentially get out of the rest of this code, because if, let's say, we've gone into here and one of these sections is true and we placed it there, we don't want to continue running the rest of the code. That's the reason we are doing throw equals -1 equals throw okay, throw -1. There we go. You can use whatever numbers you want. These are the numbers that I've chosen. Now we need to check if a piece is empty. So if piece is empty, very, very simple code for this. We're just going to do if empty piece equals asterisk grid array x, y. If it is, we're going to do asterisk grid array x, y equals AI underscore piece. And now we just need to set the texture and throw an exception as well. So I will actually duplicate all of this code. So copy and paste this, setting the texture, that's all good. To circle piece, need to show it. And for the exception, I'm going to throw -2, so there's actually some difference. And now what you want to do is go to your game state header. So if you go to your game state header file, you need to do hash include ai.hpp. Scroll down, we just need to create a AI object asterisk AI. Now in our game state.cpp, the first thing that we need to do is initialize the AI object. So if we go to the init method, we need to put this AI equals new AI, turn this data like so. So now that we've actually initialized the AI, we need to actually call the AI methods. So if we scroll down to check and place piece, scroll down to where we got check and place piece. If we go to the bottom where we've checked for an empty piece, we can actually simplify all this code. So we're not checking if the AI piece equals the turn now. We don't need to do that anymore, because that was only temporary when we could only play on our own. So if we get rid of this entire if statement, the rest of the code is almost fine. The only thing they need to change is turn equals AI piece, because we handle all of that in a different location now. So we've got the grid array equal to turn, X piece, and check player has 1 equals turn. That's fine, that's a-okay now. In the check player has 1, before we check for drawing, what we need to do is if the state isn't equal to 1, aka one of these hasn't come back as true essentially, and the player hasn't placed a piece where they could win, then what we need to do is essentially set the game state equal to state underscore AI playing, then AI place piece, and we just need to pass in a reference to the grid array. We need to pass in the grid pieces. We need to pass in a reference to the game state, like so. And the one last thing we need to do is pass in this, like so, and change this to AI underscore piece. Copy that. Okay. We've wrote quite a lot of code now, so I would always make sure, just go back, make sure that you wrote the code properly. Mistakes do happen. There's nothing wrong with that. Just make sure you've got everything where it is. Because I made that mistake in the previous video. Instead of putting x3 and y3, I put x2 and y2. Make sure you haven't done any of that. And if you're all good to go, let's run it and let's see our AI functioning, hopefully. Successfully built, fantastic. So now, click play. I'm going to place the piece here. AI is placed in the center. Remember, he can't win at the moment and he can't block us from winning, so he's put it into the center. Place a piece here. The next condition is, it goes through the conditions. Can it win? No. Can it prevent us from winning? No. Can it put it in the center? No. But it can put it into one of the corners, so it puts it into the corner. Place one here. It blocks me from winning, but I can still win. And now this is game over. So now let's have another go. Let me do it. So I put it here. And now I'm going to put this piece here. And therefore, you can either block me or win. The logical decision is to win, because there's no point blocking me, because if they win, I can't do anything anyway. So that is it for the AI. If you have any questions, feel free to post them on my educational platform, sonarlearning.co.uk. At the moment, we don't actually go to the game over screen. We'll be implementing that in the next video. If you want to check out the source code from this video, please feel free to check out the GitHub link, and there will be a link to that with this video. There will be source code for all of this series, and as usual, thank you for watching and I hope you have a great day.